It has been said that water was observed on the super-Earth exoplanet K2-18b. If the observations are proven, it will mark the first time we have found evidence of water on an exoplanet, a necessary component for life. In 2019, two independent research revealed that water vapor had been found in the exoplanet's atmosphere for the first time. However, the nature of K2-18b and its potential habitability ignites more hotly debated topics and questions. So in this video, we'll delve deeper into these. Discovered in 2015 by NASA's Kepler spacecraft, the exoplanet K2-18b is a fantastic candidate for a bizarre holiday getaway, as it is just about 13.3 million miles from its host star. It completes one orbit in approximately 32.9 days. This is a massive find since the alien planet appears to be habitable, orbiting its star at just the life-friendly distance for liquid water to exist on the surface. However, this doesn't make K2-18b a carbon copy of Earth. On the contrary, the two are very unique from each other. Unlike Earth, it revolves around a red dwarf or an M-type star, which is considerably fainter and smaller than our own Sun. Its diameter is about 2.3 times the Earth's, while its mass is about 8 times more. It's also merely 124 light-years away from Earth, so a voyage there using conventional rocket power would take over 2 million years, making it ideal for those who enjoy long-haul flights. At least two research teams have detected water vapor on K2-18b. Water vapor makes up between 0.01% and 50% of the exoplanet's atmosphere, according to one of the research teams. Given the large difference, describing the true colors of the exoplanet makes it challenging. Meanwhile, another team of researchers proposed an alternative explanation. They requested using the Hubble Space Telescope to observe K2-18b as it crossed in front of its host star once every 33 days. After each transit, the atmosphere is illuminated by the star's light. However, not all of the starlight makes it through, as certain frequencies are absorbed by substances in the atmosphere. Specifically, water absorbs near-infrared light at certain wavelengths, making water vapor visible. After organizing and cleaning up the data sets from the transits, they discovered a trace of water vapor. According to these researchers, K2-18b has a hydrogen-dominated massive atmosphere with just driblets of water vapor. Like Earth's atmosphere, an alien world's atmosphere can shield its surface from the harmful effects of a star's rays. K2-18b's surface may be covered from the red dwarf's radiation if hydrogen predominates in its atmosphere. This is because hydrogen is very light and easily dispersed by stellar radiation. But since it has such a massive atmosphere, we wouldn't recognize the concept of a surface at all, at least not in the same sense we do here on Earth. Likewise, the planet's average temperature is a big unknown. According to experts, the surface temperature is between -100 and 116 degrees Fahrenheit. This implies that the surface may be colder than Antarctica or hotter than the Earth's scorching deserts. Knowing the mass and diameter of K2-18b helps us better comprehend its gravitational influence. Suppose the majority of the exoplanet is composed of solid rock and ice. In that case, a person visiting there will experience a feeling of weight that is 37% more than what they would experience on Earth. As mentioned, some scientists view K2-18b as a super-Earth. There are many known super-Earths, which are larger than Earth but smaller than Neptune. Although most are expected to be rocky like Earth, they may also be a mini-gas giant, or Mini-Neptune, with a radius of roughly 1.6 to 2 times that of Earth. Despite observing water vapor in the exoplanet's atmosphere, K2-18b was not considered habitable. This is because most astronomers categorize the planet as a mini-Neptune. Neptune-type planets have thick hydrogen clouds with no identifiable surface. For the same reason, worlds like Neptune and Uranus are inhospitable to life as we know it on Earth. They have thick, suffocating atmospheres, a lack of a hard surface. But launching in 2028, the European Space Agency's Ariel mission will perform an in-depth exploration of the atmospheres of around 1,000 exoplanets. Together, the Ariel and the JWST will help us learn a great deal more about K2-18b and other exoplanets like it. Since water has been such a catalyst in the quest to discover the cosmos, how can scientists go about detecting it? They use optical telescopes. These visible light-collecting telescopes only offer a rough idea of a planet's size and components. This is because they can only see in the visible spectrum. Carbon dioxide can crystallize into a reflective solid at freezing temperatures. Therefore, it is challenging for optical telescopes on their own to confirm the presence of water due to reflective surfaces on some of these exoplanets. They also find signs of water by analyzing the light emitted from the exoplanet when it transits in front of its star. By analyzing the starlight's absorption spectra, they can tell if the planet has water in its atmosphere and how much water there is. Light of different colors or elementary particles like neutrons emitted from an exoplanet surface are also detectable by additional sensors. Detecting water on planets and moons outside our solar system is a challenging task, and it's only one component of the maze of obstacles that must be crossed in order to find life. But it's not just water that's necessary for life in space. There are plenty of other factors. Carbon is one example. It's the basic ingredient required to make complex organic structures like proteins, carbohydrates, and lipids in living creatures. Since carbon is essential to life forms here on Earth, it stands to reason that similar carbon-based life could exist on other planets. Next up is nitrogen. While carbon is undoubtedly a key building block for many organic molecules, it can't stand on its own. DNA and RNA, which carry the Earth's genetic code, require nitrogen as an ingredient. Therefore, the detection of nitrogen could provide key evidence supporting the existence of bioactivity on exoplanets. Phosphorus is another ingredient, and just like nitrogen, it is essential for the production of DNA and RNA. Because the phosphate group in DNA functions as a kind of glue, the bodies of living beings cannot function properly without them. After that, we add time as a necessary factor. It takes billions of years for life to evolve from simple to complex, and we can't speed up the process. And finally, it's all a matter of luck. It's mystifying that the Earth has maintained a stable and habitable climate for so long. Even while Mars used to have habitable temperatures, none of our planetary neighbors currently do. Earth has an acceptable temperature today and has maintained this for the past 3 to 4 billion years, an extraordinary length of time in astronomical terms. Exoplanet discoveries show that billions of Earth-like planets are in our galaxy alone. But what has kept Earth habitable for such an incredibly long period? Luckily, Earth is home to all the necessary elements. And Earth, a teensy planet amid a gigantic universe, is fortunate to have enough of the substances needed to support such a rich diversity of life. Asteroids, solar flares, and significant geological events like supervolcano eruptions are just some things that can continuously disrupt a planet's stability. Sure enough, an asteroid strike 66 million years ago wiped off a massive percentage of Earth's animal and plant life, including the dinosaurs. We may now appreciate that luck, at least in part, was responsible for the Earth maintaining its habitability for so long. For example, Earth might no longer be habitable if a slightly larger asteroid had struck at a different time, or if we keep setting annual max temperature records. Now, is K2-18b lucky enough to accommodate life? Most scientists believe that the planet is a mini-Neptune, drastically reducing the likelihood of it harboring life. Although water vapor is a fantastic discovery, the presence of chemical nutrients and bodies of liquid water is essential for life to exist. Let's add that orbiting a red dwarf makes the planet prone to lots of flares, which combined with the high energy levels already present, can greatly inhibit the planet's ability to support life. There may be planets in the universe that host life forms despite having merely a gaseous atmosphere. However, K2-18b does not appear to be an ideal place for this kind of life, at least not for the life similar to that which exists on Earth. How about you? If a planet is to be considered livable, what do you think is the most necessary feature? Share your thoughts in the comment section below. Don't forget to hit the subscribe button and leave a like. Thanks for watching.